Right, so continuing our discussion on set operations, we will be working on the next part. So we already talked about complements. We also have what we call as the intersection. Okay, so when we say intersection of sets A and B, what are the elements? So we are talking about the elements common to both A and B. Okay, so the symbol for intersection is like an upside down letter U. Okay, now if you would remember, if we have our Venn diagram, okay, the intersection, the overlap, that is your intersection. Okay, so that is how it could be visually represented. That is where you look at when you're looking for the intersection of sets. Okay, so let's take a look. Find each of the following intersections. So here, we do not have any Venn diagram. So all you need to look at is look at all the elements of both sets. What are common? What elements are found in both of them? So the intersection of these two elements, so first element, these two sets, first set is 7, 8, 9, 10, 11. Second set is 6, 8, 10, 12. So the intersection is, so do you have 7? No. Do you have 8? Yes. Okay. 9, you don't have it. 10, you both have it. 11 and 12, none. So you can see that the only common are 8 and 10. All right. Now let's have this next example. We have 1, 3, 5, 7, 9. Intersection with 2, 4, 6, 8. Do we have anything common? As you can see, these set are all odd numbers and these are all even numbers. You can see that none of the elements are common. So in this case, we have an empty set. Okay, you can write it like that. Or again, the other symbol would be this symbol, like you have a circle and then like you're canceling it. Okay. Next, we have the set 1, 3, 5, 7, 9 intersection with, excuse me, the empty set. Well, the fact that there's nothing inside an empty set means there is no intersection with any set. Oh, my bad, I'm sorry. So again, for this one, our answer here is the empty set. Okay. Now, the opposite of intersection is what we call as the union. Now, it's easy to remember union because the symbol of it is like a letter U. So, U, union, if it is the upside down U, it's the intersection. So, when we talk about union, okay, from the word unite, you mean all of it, okay? You are combining, okay? So, they are all the elements in both. All of them, you just add all the elements in both sets. So if you're going to represent it, okay, let's say this is set A and this is set B. When we talk about the union, it's going to be everything inside this circle, everything there. That is the union. All of this inside this two circle, that is your union, okay? So let's take a look here. So again, similar example, but this time we have the union symbol. So we just simply combine all the elements together. Now, if there are common elements, remember we do not do repetition. So that element only is counted one time. All right. So if we add or we combine, not add, if we combine these two sets, we start with 6. Let's just have it in order just so it's easier. 6. We got that. 7. Okay. We got 8. 8 only appears one time. We got 9. Okay. We got 10. So that. 11. And then 12. All right. So that is your union. Okay. Now, if we have this next example, 1, 3, 5, 7, 9, 2, 4, 6, 8. Again, just combine all of it. So we can start with the smallest one, 1, and then 2, 3, followed by 4, 5, 6, 7, 8, and 9. Okay. So if you will notice, I am trying to like mark what I have already listed just so to lessen my confusion. making sure that I did not miss any of the elements. So like I said, it is very important. If you visualize it, if you draw it, if you need to like list them down and mark them on your own. Okay. Now, what is the union of any set with an empty set? Well, you're not adding anything. You're not including any new element because it's an empty set. So pretty much the union of any set with a union set is still the original set. Okay, so that's that. So important thing to remember, okay, when you are using the empty set in an operation. So let's say A intersection of the empty set, there is no intersection because this is empty. When we talk about A union of the empty set, so you are not adding a new element, you're not listing down some more elements. So it's just what was the original set. All right. So let's take a look here. Now, if you will notice, okay, if you take a look at these two examples, we have like multiple operations. So you can see that we have the union, and then also a complement. So those are the three operations that we're going to be working on with sets. Complement, intersection, and union. All right. So given that we don't have any Venn diagram, our reference will always be the universal set. So our universal set is from the numbers 1 up to 10. 1, 3, 7, 9 is A. 3, 7, 8, 10 is set B. Now, when you have multiple operations, set operations involved, it's pretty much like PEMDAS. You start with the parenthesis first. You start with the most immediate operation, okay? So in this case, the union of A and B complement. So before you do the complement, you need to work on the A union B, okay? So what are the elements in A union B? So this is A, this is B. You just combine them into one set. So you have 1, 3, 7, 8, 9, and 10. Okay? So that is the union. Now, according to this, whatever was the union, we need to find the complement of it. So what is not, okay? So that now is our second operation. What is not in this set? So 1 is there. So where do you refer? Again, refer to the universal set. So 1 is there, 2 is not. So 2, 4, 5, 6, 7, 8, 9, 10. Okay, so it's just 2, 4, 5, and 6. That is how you can look at that. Okay? Now, let's have this next example. So you have to have the intersection of A complement and B complement. Now, you cannot find the intersection unless you know what is not A and what is not B. Okay? So let's start with the complement of A. The complement of A is anything that is not in here, not in set A. So that includes 2, 4, 5, 6, 7 is there, 8, and then 10. Okay? B complement. So what is not in B? So what is not in set B? You have 1, 2, 3 is there, 4, 5, 6, 8 is there, 9, and 10 is there, so up to 9. So now that you have the complements of the two set, now you can find their intersection. So what is common between A complement and B complement? So you can see that both of them have 2. Okay, both of them have 2. They both have 4. They both have 5. And also 6. Okay, so happen that it's also the same answer over here. Okay, so that is how you can work with multiple set operations. Make sure that you find what is the innermost operation in the given. All right, now let's take a look here. This time we have Venn diagrams, okay? So we can use, in this particular set, this particular example, we'll just use the the area number. So our answers would either be Roman numeral 1, 2, 3, or 4. Okay? So let's start. We have the A union B. So A is 1, 2. Okay? 1, 2. And then B is 2, 3. So everything in the circles. So that would be area 1, area 2, and area 3. That's the union. Okay, everything in this circle. Now, so A union B, complement. So what is not in this? So this is the union, okay? Everything in these circles, okay? What is outside of that union, that is area 4, okay? So that's how we work it out. Next, we have A intersection B. Oops, sorry, I got it wrong. So A intersection, so intersection is the overlap, and you can see that that overlap is area 2, okay? Now, area 2 is the overlap, the intersection. So now we're looking for A intersection B, that whole thing complements. So what is not area 2? So you can see that that would be 1, 3, and 4. Okay? 1, 3, and 4. All right, so let's take a look next. It says here, A complement. All right, so let's take a look here. A complement. So what is not A? You can see that this is our A. All right. So not A is area 3 and 4. And then you have to get the intersection with set B. So set B is just 3. So in this case, not A, union B, intersection B is area 3. Okay? So not A is 3 and 4, but the intersection with set B is 2 and 3. So you can see that that answer would be area 3. Okay? So next, last example here, we have A, set A. Okay, set A, this is set A. Union of not B, not B, okay? So, hold on. Let me just go over this first, okay? So our B is this, okay? This is B. So the union of set A and not B, so this is B, 2 and 3 is B. Set A is going to be area 1, and then not B is area 1 and area 4. So in this case, the union would be area 1 and area 4. Okay? Area 2 is not included because area 2 is part of B. So there's only 2 areas being described in here. Okay? So if you would like to take a look, the list of the elements, they are all on this part here. Okay? Now, last thing, if you have the words or and end, okay, just always remember that the word or is the union, okay? And if you have the word and, that is the intersection. So or is all of the elements, and is what is common. What are the common elements? And pretty much that's everything for set operations.